Hello and welcome to today's video, where I'll be using JoeSandbox, a powerful tool for dynamic malware analysis, and the spyware sample in question I'll be using is a Trojan. After browsing to the JoeSandbox Cloud Basic website and signing in, you'll be prompted with a few different options for your dynamic malware analysis. In this video, I'll be choosing Windows. The sample I'll be using, you can also specify which VM system you want to test in. I'll be choosing Windows 10. You can use a live interaction. You can set the execution runtime if you do have the paid version. And then you also have these advanced settings where you can turn off internet access. I'll be leaving that on. Collaboration. The sample will be shared within the JoeSandbox community. And then after agreeing to the terms and conditions, we can begin the analysis. This will take a few minutes, so I'll come back once it's all ready to go. After the analysis begins, you can see I have a 2-minute timer in where I can interact live with the malware in a virtual machine within JoeSandbox. If you want to add additional time, you will need to pay for a higher tier level of the service. After the analysis, JoeSandbox will clean up the virtual machine and prepare our report for us. After the analysis, JoeSandbox provides us with a little bit of information about the malware we've just executed. We can see here it shows us some different YARA rules where it detected a Metasploit payload being executed on the virtual machine. JoeSandbox also has an API to Reversing Labs and VirusTotal where I can get a detection rating from each vendor, and this malware scored quite high. The 3 important YARA rules it was able to detect was the Metasploit payload, that the Trojan opens up a reverse shell, which is most likely to exfiltrate data from our virtual machine. We have some IP addresses here, which we can further investigate in the report, and then some interesting domain names as well. So here I have the Windows analysis report. An important thing to note when running your malware within the JoeSandbox environment is to not interact with the virtual machine. The reason for this is that you don't want to add any sort of traffic or logging into the report that isn't directly from the malware being analyzed. If you were to open up File Explorer and browse to a website, it's going to be contacting different IP addresses, which may not match with the IPs of the malware. Here we have the process tree of our Trojan. We can see after the execution of the application, it runs this executable, where it looks like it creates a local server and encrypts it with MD5. There's some activity with Adobe Acrobat, where Acrobat opens this PDF, and this more than likely, upon execution, can lead to the execution of embedded malicious code. And this can allow the attacker to install malware, steal information, and take control of the victim's machine. After Adobe Acrobat opens this PDF, it looks like it installs an executable, and this then performs some code, and after it cleans up. JoeSandbox classification of the spyware leans heavily towards Trojan, which employs a lot of evasive tactics. We can see here there's a lot of reference to Metasploit. Using Metasploit as the attack vector include remote access and control. Because it can establish a backdoor, this allows attackers to remotely control the infected system. And the way that the Trojan does this is by contacting an IP address in China, which serves the purpose as the command and control center, and this is where it can retrieve the Metasploit payload. The YARA signatures are extremely important because it can tell us a lot about what the Trojan is attempting to do. It is noted that within the YARA signature, a Metasploit WinnyNet reverse shell has been executed. This is a feature within the Metasploit framework and allows the attacker to gain command line access to the victim's machine, enabling remote control. The 64-bit Metasploit WinnyNet reverse shell code used by Metasploit is an API hashing function and is often referred to as JA3. JA3 is a method for creating a hash based on the SSL/TLS handshake. We can see later on that the JA3 hashing function was also picked up by Suricata in its network analysis through its emerging threats rule set. We can see the only URL contacted which Avira, a popular antivirus vendor, was able to flag was that address in China, where it appears to retrieve the Metasploit payload. Avira's URL cloud has labeled this as a phishing attack. We can see under the found malware configuration, a Metasploit connect was retrieved from this URL, found here at the beginning, and then some other detections such as one from VirusTotal and Reversing Labs, just for further confirmation that the executable was malicious. A really great feature of the JoeSandbox malware report is that it includes a breakdown of the MITRE attack matrix. The MITRE attack framework enhances understanding of malware by providing a structured and detailed approach to analyzing adversary behavior. Strong characteristics of this Trojan is that it is sophisticated in defense evasion, discovery, and command and control, while it also tries to escalate its privileges in when downloading and running executables on the virtual machine. The behavior graph of this Trojan can show us that after running the original executable, it contacts this IP address in China for command and control. It then executes Adobe with a PDF, which leads to the execution of some embedded malicious code, which runs a further acrosef executable, and makes changes to the machine through the likes of DLL files. For this table in the report, we get a label from Reversing Labs, which identifies the Trojan as being Windows 64 backdoor interpreter, where it creates that backdoor connection to a server in China. A viewer has also given this Trojan a label. Analyzing this label can show us that the TR indicates that it's been classified as a Trojan. The crypt part suggests that the file uses encryption or obfuscation techniques to hide its true intent or payload, thus making it harder for security software to detect its malicious nature. The XPact specifically refers to the packing method used to compress and to obfuscate the executable code. And packages like XPact are commonly used by malware authors to evade detection, which reinforces the strong evasive techniques this malware uses. The Gen 7 indicates that this is the 7th generation of the detection, and this detection is based on behavioral or a heuristic analysis rather than a specific signature. Every single IP address that is reached out to is given a detection rating, and these are all mainly flagged as 100% malicious through vendors such as Avira and VirusTotal. We also have some statistics on the virtual machine. The main executable in question we can see has the highest amount of CPU usage, and then our original executable doesn't have the highest amount of memory usage but consistently uses memory throughout the execution. There are more changes made to files, either through creation or modification, than any registry keys. And then the most behavior again is from the executable, which is run through the embedded code in the PDF. A final section of the malware analysis report that goes into more depth about the evasive nature of this Trojan is that it outlines that the original executable has a thread sleep time on it, and this can assist the Trojan in hiding within the virtual machine. It also shows that the sample execution stops while the Trojan is sleeping, and its last function is listed as thread delayed. And then it also shows that the Trojan may be able to detect the virtual machine to hinder our analysis, and it's able to find virtual machine artifacts in the device's memory. And we can see that it's identified the hypervisor, binary, or memory string. Thanks for tuning into this video, where we perform some dynamic analysis with JoeSandbox on a random Trojan sample that was obtained from Malware Bazaar.